Today, we are tackling a story that took 50 years to unfold. We're on the hunt for a particle so fundamental that, well, without it, stars wouldn't shine, planets wouldn't form, and you and we wouldn't exist. This is the story of the Higgs boson. These might sound like huge philosophical questions, right? But they're actually at the very heart of physics. And the answer to both involves this epic 50-year hunt for a single, incredibly elusive particle. Yeah, I got this really dramatic nickname, the God particle. So what is this thing really, and why did the entire world of physics literally build the biggest machine in human history just to go looking for it? Okay, let's dive in. For decades, physicists were facing a really big problem. They had this amazing rule book for the universe called the Standard Model, but it had a massive hole in it, a fundamental question it just couldn't answer. It was all about mass. See, they knew that some particles, like photons, the particles of light, are completely massless. They just zip through the universe at the ultimate speed limit. But then you have other particles, like the electrons in your atoms or the quarks that build your protons, and they clearly have mass. So why? Why are some particles heavy while others weigh absolutely nothing at all? And look, this wasn't some minor detail they could just sweep under the rug. This was a gaping hole in their most successful theory of reality. Without a good explanation for mass, our whole understanding of why matter and stars and galaxies can even exist was, well, it was fundamentally broken. And then, back in 1964, a physicist named Peter Higgs, along with a few other scientists working on their own, came up with this radical solution, an idea that would totally change physics forever. Here was the big idea. What if mass isn't something a particle has, but something it gets? The theory was that the entire universe, every single bit of empty space, is filled with an invisible energy field. We now call it the Higgs Field. And this analogy is probably the best way to get your head around it. Imagine a particle moving through this field. If it interacts a lot, kind of like a celebrity getting mobbed by a crowd, it gets bogged down. That drag, that resistance to moving, is its mass. So particles that interact less, they have less mass. And particles like photons, which don't interact at all, they just slip right through, completely massless. It's the field itself that gives particles their mass. It was a really beautiful, elegant theory, but it presented a huge challenge. I mean, how on earth do you prove that an invisible, all-pervading field actually exists? Well, here's the thing about quantum physics. You can't see the field directly, but every field has its own special particle. So just like the electromagnetic field has the photon, the Higgs field should have its own quantum particle, the Higgs boson. If you could find that boson, that would be the smoking gun, the definitive proof that the field is real. And so, the greatest hunt in the history of science began. And this was a marathon, not a sprint. It took decades. It involved thousands of scientists from all over the world. The search started with early colliders at CERN in the 90s. Then the Tevatron in the United States picked up the trail, until, finally, a new machine was built, one designed specifically for this exact task. To find this one single particle, humanity built the Large Hadron Collider, the LHC. It's this gigantic 27-kilometer ring buried way underground on the border of France and Switzerland. Inside, tiny protons are accelerated to 99.9999991% the speed of light, and then wham! They're smashed together, creating these tiny fireballs of pure energy from which new particles can pop into existence, just for a fleeting moment. All right, let's get to the climax of the story. After years of building this thing and after trillions of particle collisions, the moment of truth was finally here. So it's July 4th, 2012. Picture a packed auditorium at CERN. The world's media is watching, and the announcement is made. After sifting through just mountains of data, researchers from two completely separate experiments had seen the exact same signal. They had discovered a new particle. It had a mass of about 125 giga-electron volts, and it was behaving exactly as the theory predicted the Higgs boson should. It was an incredibly emotional moment. Peter Higgs himself was actually in the audience, wiping away a tear. The half-century search was finally over. And you have to understand, this wasn't just finding another particle on a list. This was the capstone of the Standard Model, the final missing piece of the puzzle. The discovery confirmed that our fundamental understanding of how the universe works was, in fact, correct. It was just a massive triumph for human curiosity. So, the Higgs boson was found. We know the Higgs field gives particles their mass, and without it,
electrons would be massless, just zipping around at the speed of light, never forming stable atoms. So no chemistry, no stars, no planets, and definitely no us. But hold on, there's one final absolutely stunning twist to this story.
You'd think that the mass-giving particle would be responsible for, your mass, right? But the answer, surprisingly, is no. Not even close. So get this, if you add up all the mass that the fundamental quarks in your body get from the Higgs field, it only accounts for about 1% of your total weight. 1%. So where does the other 99% come from? It comes from pure energy. The quarks inside your protons and neutrons are just furiously jiggling around, held together by this incredibly powerful, strong nuclear force. The energy of that interaction, that binding energy, is just immense. And thanks to Einstein's famous equation, E equals mc squared, we know that energy and mass, they're really two sides of the same coin. Most of what you call your mass is actually the concentrated energy of these tiny particles buzzing around inside you. So the discovery of the Higgs boson didn't just find a particle. It completely changed how we think about mass. It's not some solid, built-in thing. It's a relationship. It's an interaction between a particle and the cosmos around it. The Higgs boson was the key that unlocked this really profound truth, answering not just why things have weight, but giving us a glimpse into that much deeper question of why we and the entire universe exist at all.